Good morning everyone. So today we will go for interfacing embed board with LCD and check whatever data we are going to print will come on the LCD display. Before going to LCD interface, we should know about some LCD command. This LCD command are listed here. So this is the first command, 030. This command is actually used for setting up your 8-bit data on the first line for microphone matrix. Basically, before going on other next command, you should know that all the commands which are listed here are basically divided into 3 different categories. One is of a function setting up, second is entry and display, and third is a shifting operation. As per our needed or as per our requirement, we have to select our command whatever we needed here. So first 30. Then for setting up a second line we will use it 38. Then for 20 and 28 for 4-bit operation we will use 06 is essential to give or LCD entry mode. Then 08 is for display of cursor off, so basically no light will be there, no cursor will be there, just whatever data we will give we will print that only. On 0E it will be like cursor on, display on, so light will be there and cursor will be on. Next one will be 0C. 0C on that display will be on and cursor will be off, so whatever the data you will give that will be shown on the display on. Next is 0F. 0F is a display on cursor blinking. As we seen on our word file and everything, like here you can see cursor is blinking. So such operation also we can get on LCD by this 0F. Then next shifting operation, this last 4 one is 18 and 1C. This will shift entire display left and shift entire display right respectively. And 10 and 14 is no cursor left by 1 character and no cursor right by 1 character. As per our needed, we can use this command. Two more important commands there. 80C0, it is just for initializing the display. If you want to work on if you want to write your data on a first line, then you have to use 80, and if you want to write on a second line, then you have to use C0. Now let's go to the program and we will see how to interface of our LCD will work. First, as it is your embed board, so you have to include the embed board HDFI. Then you will use the south command. I even given a choose with the whole entire bunch of wires to make bus, that is a dead, and pins are the P23, 24, 25, 6, then go for 29 and 30, and then 33 and 34. In between that 27, 28 and 31 and 32 are used for I2C and USB, so I didn't use. I'll just go take another GPIO. That's it. And to another GPIO that I defined with the RS and T, that is P21 and 22. The RS is a register, it's a register set signal. What it will do, if you put it for 1, then if you, whatever data you give a data, it will consider as a data. Whatever the command you will give, it will consider as a data. Otherwise, whatever you will give numeric value, it will consider as a command. So that is you will see on next letter. Then E for enable and P22. This thing is the same for enable. These two things we have to set before any interface of LCD. Then after that, these are the few functions I just defined here. Two functions for command and data. One is for word, whatever word we want to print here, I can write here. And one is for initializing, and next one is for clear. So now let's go to the main function. Inside the main, what I did, I just call LCD init, that is LCD initializing. For initializing of LCD, I have to write few command that I explained here. First command is 38. Already we seen the function of this all the thing. Set the first line, then 0E, then 01. 01 is for clearing the thing. so no garbage will come in your display. Then 06 and 80, I already told you it is for setting the first line. So whatever I give data, it will start from first corner of the LCD. And if I write 8 then first actually 16 bit, if the LCD is 16 plus 2 bit, right? So it will start from just next letter of the LCD. When I write 81 here, but I write 80 here, so it will start from first bit. Then again it will come back here, and it will go to the LCD world, because I call the function LCD world here, and give my whatever I want to print. I'll just write character here, that is hello world. So when I call it, it will directly go to this function LCD world, and here I define whatever I write inside the bracket, it will be character type, and I use one pointer, that is a string. Whatever I write, it will store here, and it will check whether it's 0 or not, and again come back inside the function. Inside the function, what will it will call another function, that is LCD data. As we already seen the LCD command function, the next is the LCD data function, where I told what the RS printer. So when it calls from here, it comes here, and I put the RS in 1, so whatever I write inside the bracket, it will consider as the data that needs to be printed. So it will go here, that variable name date, and consider it, and these are my enable 0 and 1 pin. And again it will come back here, wait for some time, implement the string, and one by one that will come, and all the data whatever I actually give command, that is a hello v18, and by one all the data will come and print on a display. And when I use RSS 0, because all the command is called by the function LCD command. So when I call the function, I have to write my RS is 0. So it will not consider as a numeric data to print, it will consider as a command to do functionality. So by writing this program, you can see the output. Here you can see this is my embed board. It is connected with a USB cable, and I already load the program, bin file I loaded, and here is a P20 number, P21 pin is there, the first pin for RSM enable, and then next bit, all the pin is connected to the data pin, and last 2 pin of LCD, that is LED plus and minus, are connected with the VCC and ground respectively. And in the video you can see I give the command, give my letters to hello v18 to print, and it will print on LCD. How to interface our different sensors, analog sensors, with our Android board. So here we choose the platform, that is Android. It is a product of NXP, FPC11V24, and I will use the analog pins of this Android board. Actually the analog pin is P15 to P20. So I'll use last 3 pins, P18, 19 and 20, and how to write a program, and how to dump the program inside our board, that we will see. First we will go to the website of android.org, and we choose our compiler, online compiler here, and I'll create my console file here, and now I'll write the program. First, there is its console file, so we have to add our header file, so I will include that. Next thing is whatever the analog output coming from my sensor,
sensor that I have to display on my serial terminal of my laptop. So I have to define serial terminal of the board, that is USB transfer and receive. So how to define it? You have to write CV as unit serial communication. Give some serial name and name it counts, and you have define your pin, that is USB TX, USB RX, that's it. So when you define your 2 pin, that is your transmitter issue. Then let's go further, defining your analog input pin. Like whatever the analog output is coming from the sensor, you have to take as the input of analog board. So you will define analog input pin, that is defined by the analog. As you can see, it's all becoming 0. So analog and directly should on the set of sensor name and press on 220. So again the same thing I have to write because I take 2 temperature sensor and 1 flux sensor. So 3 sensors I have, so I have to define 3 pin as the analog input. So when I have analog in, sensor 2, that is the pin I have given, and then I will third pin is the analog in. It should be concept 2, number 80. That's it. Now I will go to the main command. Write main, because it's an integer type. Write a main function. Inside the main function, I will write first. I take 3 variables. Suppose sem1, sem2, sem2, which will carry my whatever the data analog data coming from my sensor. I will give data type is a float, because all these 3 sensors give me a floating variable, so simple. Because I need continuous fetch the data. So that whatever I write. In this variable, whatever I define here, this variable will contain the value, whatever continuously reading from the variable, this pin. So I will write like this: sem1 is equal to pseudonym of this pin, that is sem1 v. That's it. So it will continuously read give some time delay. From second, then for second sensor, that is sem2 equal to sensor 2 read. Wait for all. Then for sensor 3, write. Okay, so the reading operation is completed here. Reading stays there. That's it. Okay. So after the continuously fetching of this data and storing on this variable, what I have to do, whatever the value is coming is not an actual value. So I have some manipulative factor is there. So I have to manipulate it and I will install it in the same variable. So this will be my final output. So which are these factor are I've done it. Sum1 is equal to sum1 is this sum1 will be the previous one. This will be multiplied with some factor and storing the new value of that sum1, and that is sum1 into that I'll write 48.8281. That's it. This is the factor which is manipulated by the value coming from the temperature, that is our LM3 file. This multiplication will give me the exact temperature, and same thing I can store on the temperature with 22 equal to somewhat different. That is flux sensor is there. So what I would write sum3 into 100. Now the new actual value whatever I need of this sensor is stored in this 3, and now I have to just print it simple. So what I will print here, actually I want to print this on my serial window. So for serial window I take this pseudonym trans, so I'll write here trans dot printf as the console. All the file we need to write printf on for printing the data. Okay, I have to write this sensor value. Sensor value 1 is equal to percentage f, because the what is really coming from sensor 1 to 3, it will be float, commas, and what I want to print someone. So that's why I write some of trans dot printf. Sensor So this is very simple program to interface with 3 different sensors, and after writing this I just have to save here and compile it. So after compiling, one bin file will be generated here. You have to dump it in this board whatever I selected here, PC1124. After dumping it, you will find output on my serial window, and the Teraterm software will be there, which will provide serial communication printing, whatever I want to print. So you can see the sensor value 1, sensor value 2 and 3 different values there. When I drain my flexible sensor, different value will be coming, and again temperature also will increase. So this is, and let's see the interfacing part. So this is my interfacing part here. You can see where USB I connected my breadboard. Here in the flex sensor, 2 pin will be there, one is a thin pin and one is a thick pin. So thick pin will be my negative, and thin pin is I have to connect it with my analog board. It gives the some analog voltage. So this is my flex sensor that is connected here to pin number 18. This is my two different temperature ICs there, LM35 here. You can see LM35 I have to give a positive supply, I have to give a negative supply ground, and on the center pin it will give me output, and this output will be varied to 2 sources to 150 Celsius, 0 millivolt to 10 millivolt. These are the calculation predefined by the company. You can see when my IC stop using model, it seems like D on this side curve like that. So first one I have to connect it with ground, second one is my output pin, so it will connect it to the analog input pin of Android board, and last one is a VCC. So as per this I give connection, and finally I got the out. That is simple interfacing with the 3 different sensors with my Android board. Thank you. Hello friends, so we will go to see that how to interface my temperature IC with the Android board. So this is my temperature IC and this is my actual IC. It is in LP package, and it's dual line package, and I use this IC, so 3-pin IC, and you can see the bottom view of that. So 3 pin will be there. One is voltage pin, voltage supply, and one is ground pin, and center one is Vout pin. Here for small indication you can see when D is formed. So as per the D, first pin will be the ground, and the center one will be out, where actual temperature will be out here, and the third one is my VCC pin, and my analog value is coming from the center pin. You can see here I have to connect 4 to 20 volts. I have to ground my third pin, and in the second pin I will take my voltage output in terms of 0 millivolt to 10 millivolt, there is a as per the Celsius, and this will sense up to 150 Celsius variation we can do. So after interfacing, how to write a program. So first I will go to the website embed.org and start my online compiler. Next, what I have to do, I have to create in my console file, that is I created already here, LM35, that is IC9 underscore sensor.cpp, and I have to choose my board. What I have to choose here, I have to choose my LPC 1768. If you want to change and if you want to work on here, so you can choose that one also. So I change and I go to the LPC 11U24. So after selecting your platform, you have to write a code for that, and this code are, first you have to include your embed file, header file. So include then as usual I want to print my whatever the analog value coming from the sensor with the serial terminal. So for that I'll define my two serial pin here by writing serial points as usual, defining my pin, that is USB TX and RX. Okay. Then my input pin, I will define whatever the output coming from LM35, that will directly I attach to the analog input pin, and that is the pin number 850. So login, and given pseudonym, suppose sensor, define for indication purpose. Here I use my own board for LEDs, and these are the 4 LEDs, so no need to define one by one. I will define in terms of bus. So I will try to do bus out, and given the pseudonym kind of like ABC or B, define the LED1, then I will go to my main command. Inside my main, I will write. First, I have to define one variable which can store my analog value of the sensor. So it must be float. So I will use a data by float and give variable name data log. Let's say data log. That's it. I will go to the while for continuously fetching data and displaying the data. Inside my loop, I will write. First, I will fetch my analog values from my sensor, and that can be easily written as whether I give variable name data log is equal to the whatever. The in between pseudonym is there. I will write here dot read means a reading function will be done on this pin. So sensor dot read. That's it. Next, we will use some time to do. Then one manipulation factor is coming here in the picture. Whatever the value reading from this one is not my exact value, actual value. So what I have to do, I have to convert it using one log form. That how to do it. And again I store in the same variable, so it will be easy for understanding to use it. The data log here is equal to whatever the previous will be coming, the data log into whatever the new value coming in this variable, I will directly print using my default, actually where I have to print it on CW, right? So for serial communication I have pseudonym which define my body pin. So I write my pseudonym here into that command, and what I will print is that my sensor value is suppose percentage f. Let me give a new run every time, it will be easier for me to understand. And what I want to print, that data log variable I want to print. Now I will use one indicator using this my LEDs. That is what if my value is coming more than 50, then it will indicate by LEDs some pattern. If it is below the limit, then it will indicate another pattern. So I will write when this is here. I will write data log. If data log is less than 50, then what I have to do, that is we have a pseudonym here ABC. Indicate this or 4 LEDs. ABC will be having a x value of 0.02, and if it is not there, then what I will do, suppose I will print ABC equal to 0, 1. That's simple. Okay, so this is my program, whole program. And I will check the output. My whatever the sensor value will be here coming by fetching the data. It will print here as a sensor value column, and the value whatever I coming, whatever I get. And if this value is less than 50, then it will print 02. If it's more than 50, it will indicate me 01. 01 means my first LED will be 0001. If my second LED, sorry, my data value is more than 50, sorry, less than 50, then my LED pattern will be 0010. Let's check which of pattern will become. Nothing here. After save here and compile, and you will, yeah, I have to fix my header file, but it is not anything else. After fixing, you will get your bin file, and that bin file you have to directly load in Embed Board. Okay. So you can see it's here, and my bin file is coming .bin, and this bin file I have to directly load with the Embed Board. So I already loaded it, and now we'll check the output finally. This kind of I write this pseudo code. This is my interfacing part. Here you can see here, this is my VCC pin, this is my ground pin that I connected to first and last pin of the LM35, and here this is my LM. So this is my 15 number pin is there, analog pin is there, analog input pin, which is directly connected to the center pin of this LM35. Using the software Teraton, you do select your USB port, and simply just when you connect to your Embed Board, it will print the value. So here the sensor value is written. It will be clear. You see sensor value will be written, and here the value actual value coming is written. It might be less than or greater than 50, and as per that indication of Embed Board will be shown. So you can see the sensor value is more than 50, so 50.59 is greater than it. So probably as per my code written here, if it's less than, then it will be at 02. If it's greater than, then it will be at 01. So now probably my editor will show me the indication of 01. Continuously you can see the data value is more than 50, only 50.5, 50.1, and so on, 50.5. Here you can see the LED pattern is 0, 0, 0, 1. So my condition is also indication is also fulfilled. So thank you very much for watching.